Hey guys, I just wanted to make a quick video to help you with tonight's homework. So it came to my attention in class that we might have struggled a little bit with changing our bases. So I just wanted to give you a concrete video of how to do it step by step. So let's say we had something that was in base 8 and we wanted to bring it back to base 10. Now remember, base 10 is our normal number system. So let's say we had the example 413 and it's in base 8. So what we're going to do is we're going to write down the side here, the 4, the 1, and the 3, each term of the number. Now, I'm trying to convert it back into base 10, so I'm thinking about this is currently in base 8. So I'm going to multiply it by base 8, but since it's in the 100 spot, we're going to raise that to a 2. The 1, we multiply it by 8, but we're going to raise that to a 1 since it's in the 10 spot. And finally, the 3, that's supposed to be an 8. We're going to raise it to a 0. So it should be 2, 1, 0 based off the place where they lie. So 4 times 8 squared. So 8 squared is 64 times 4 is 256. 8 to the first times 1 is 8. 8 to the 0 is 1 times 3 is 3. Now, all we do to finish this up is we add up these terms, and when we add 256 plus 8 plus 3, we get 267, and that's in a base of 10, okay? Now, keep that in mind. It takes less time to cycle around 8 than it does 10, so it makes sense that this number is smaller, right? Because if we were thinking about like that clock-like system, if we go around to 8 digits, it's going to happen more times than it would if I had 10 digits. Now, if I just made the second one, now I'm just going to change up the base to base 6 in this case. So for our second problem here, let's say we had 392 with a base of 6. Same thing. 392. This time we're going to multiply by the base of 6, but to the second power, base of 6 to the first power, and base of 6 to the 0. Now, in this case, 6 squared is 36, times another 3 is 108. 6 to the first is 6, times 9 is 54. Anything raised to the 0 is 1, so times 2 is 2. And we'll get 264 base 10. Again, the number should be smaller because it takes more time to go around 10 digits than it does 6. So because it's taking longer, it happens less frequently. Now I'm going to change this up a little bit for this next example. I'm going to say we have A 8, 4 for that base of 4 that we want to convert to 10. Now remember, we may run out of a certain amount of digits here, like we just did. So if I think about my digits, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then A is 10, okay? B would be 11 and so on. So in this case, that A, we're going to replace it with a 10, and we're going to have 108 base 4. Once we have that all squared away, though, it's the same process. So 108 times 4 squared times 4 to the first times 4 to the 0. And we're looking at 16 times 1, 4 times 0. 4 to the 0 is 1, and 8. So we'd get 24 base of 10. Okay, so there's a couple steps we could follow when we're doing this. Just one more example just to get us all the way comfortable. If we had changing binary to decimal, binary remember is a base of 2, decimal is a base of 10. So those are those names for them. So let's say I had 1.1, so I threw a decimal into the mix that I wanted to change to a base of 10. I'm still going to write that out, 1.1. But now think about the placeholder. This here is the 1 spot. So when I multiply base of 2, which we were because of the binary, I'm only going to raise it to the 0 because I'm already in the ones place. Now, when I do that decimal, I'm going to do 2 to the negative 1 because it's 1 to the right of the decimal. So here, when I multiply 1 times to the 0, so we're going to get 1. 2 to the negative 1, remember, that's going to be 0.5. And then we'll get 0.5, and we're going to add these things together for 1.5. And that would be a base 10. So the rules that we can kind of gather here are actually, yes, excuse me, I'm going to actually give you some examples to try first. So you get A, B, and C. Now these are already on your homework sheet paper. So go ahead and pause the video here and try those on the own. We'll go over these tomorrow in class. But go ahead and pause your video. All right, welcome back. So basically our steps to rewriting base of 10 is to stack the number vertically, multiply each digit of the number by the base you started in, and raise it to the power of where the digit lies. So if you're the third placeholder, like if I had a digit like this, we're raising it to the second power. Here to the first power, here to the 0. Okay, if I had this one, we'd raise it to the third. It's all about how many zeros you end up having. Okay, but we just write those out and we add each of our multiplied digits together. Now this changes up when we go from base 10 to base 2. So this is the part where it gets a little bit more confusing. This is the part that we talked about, the division. So what I want you to do to organize your ideas, I think might be a little bit more helpful than what we did in class, is to start by making yourself this table. Now, I'm going to try to rewrite 18 into a binary number. So I could call it 18 base 10. We don't need to because remember our number system already is base 10. But I'm trying to convert it to base 2. So I'm going to divide by 2. I'm starting with 18, and I want to keep track of my remainders. Because when we first started this, we've just looked at the remainder in general. So now what I want us to do is divide 18 by 2. Well, we get 9, and there's no remainder then. But since there's still a number here, I'm going to do this again. I'm going to divide by 2. I'm going to repeat that till my middle column gets to a 0. So 9 divided by 2, well, it doesn't go in evenly, but I do know I could do 8 divided by 2, which would be 4, and then there'd be 1 remainder. But again, my middle column's not at 0 yet, so I'm going to divide by 2 again. This time, 4 divided by 2 is 2. There's no remainder, but still my middle column, it doesn't have a value of 0, so it means I'm going to do this again. 2 divided by 2 is 1 with no remainder, and still one more time I don't have that remainder. So now I'm going to do 1 divided by 2. Well, that doesn't go in nicely, so that's my 0. Can't be done without a decimal. There's 1 remainder, and I can stop there. Now, when you read the remainders to get your number, we're going to go from the bottom to the top. So I'm going to have 1, 0, 0, 1, 0. And that would be equivalent to 18 base 10. So let's try this again with a different base. So I'm going to try it with base 6. So still what I would recommend you do is set up that table that we just did just to keep your ideas organized. I think that helps the most so far. So we have the example of 384 that we want to change to base 6. So same thing, 384 divided by 6 actually does work out nicely, right? So 384 divided by 6, we're left with 64 with no remainder. But notice we don't have a 0 in that middle column, so it means we do it again. So 64 divided by 6 this time, well, that does not go unevenly. But we know 60 divides by 6 nicely to get 10. With that means we'll have a remainder of 4. Again, my middle column's not 0, so I'm going to divide by 6. 10 divided by 6, we can do that once. Oops. So that we would get 10 divided by 6 once with a remainder of 4 again. Almost there. Now I can't divide anymore, so we have 0 with a remainder of 1. So that, again, we go from bottom to the top. So we'd have 1, 4, 4, 0 with that base of 6 there. Okay, let's try that again. Now we're going to change a decimal to a hexadecimal. Now remember, that just indicates that we're talking about a base of 10 to a base of 16. So the hexadecimal is 16. So we're going to try 242 base 10, changing it to a 16. Now, when I do something like that and I make my table, I have my number 242. I'm dividing by 16. And I'll keep my remainders in that column. So 242 divided by 16 does not go in nicely, but we can get 15 with a remainder of 2. Now, unfortunately, we don't have 0 in that middle column, so we divide by 16. But 15 can't be divided by 16 with any pieces, so there's no whole number there, but that means there is 15 as a remainder. Now we've got that middle column to 0, which is what we want, and we do read it from top to bottom, 15, 2, but be careful. Notice that the 15 that's indicated, that represents one term. So because it represents one term, we can't leave it as a 15 because that's 2 digits. So we think about our 0 through 9, and then A would be 10, B would be 11, C would be 12, D is 13, E is 14, and F is 15. So now that I've made it to 15, I'm going to change this to F2 and a hexadecimal. So remember, if you have something that comes out as a double digit like that, we start going through our letters to help us be able to write that. So for each of the following, we're just going to change to our indicated base. Okay, so I believe you have 3 more questions on your worksheet. Try those. So basically, the 2 sections that say try on your own, those are the ones that you are completing for homework tonight. So A, B, and C of the first half, and A, B, and C that's indicated now. We'll go over them tomorrow in class, but hopefully this video helps you clarify when to do which one, just so we're all on the same page. Okay, guys, thanks for watching.